the most misunderstood organ in your body. Fat might be the most hated thing humans carry around. It gets blamed for laziness, mocked as a lack of discipline, reduced to aesthetics, jokes, and shame. But that story is not just cruel, it's scientifically wrong. Because fat isn't just extra weight. Fat is an organ, one of the most misunderstood in the human body. A living communicating system made of billions of cells that stores energy, protects you, and sends hormonal messages that help run your entire body. You literally need it to survive. Without enough body fat, humans can run into infertility, weakened immunity, depression, fatigue, and fragile bones. Fat isn't optional. It's part of what makes you function. And yet, when we carry too much fat for too long, especially in certain places, this organ can shift from helpful to harmful. It can become inflamed, stressed, and chemically loud. And it can help push the body toward diabetes, heart disease, fatty liver disease, and several cancers. Globally, obesity has become so common that in 2022, about 1 in 8 people worldwide were living with obesity, and adult obesity has more than doubled since 1990. So how did we get here? What is fat, really? Why does it become dangerous? And, most importantly, what actually helps? Let's talk about the organ you were never taught to respect. Why your body was designed to gain weight. To understand modern obesity, we need to understand something uncomfortable. Your body is not designed for modern life. For most of human history, getting food required effort, risk, and time. You didn't grab calories. You hunted, gathered, waited, failed, and sometimes went hungry. So evolution did something logical. It built a body that defends energy, a body that treats calories like treasure. When food is uncertain, the best survival strategy is to store energy when you can and spend it carefully. But then, in evolutionary time, basically instantly, humans built a world where food is abundant, ultra-processed products are cheap, eating requires almost no effort, physical movement is optional, and marketing is everywhere. Many ultra-processed foods are engineered to be hyper-rewarding, a powerful combo of fat, refined carbs, salt, flavorings, texture, and speed of absorption. For brains built to seek rare energy, it can feel like hitting a jackpot, again and again. Researchers increasingly discuss addictive-like patterns in some people with ultra-processed foods, and the science is actively developing. And here's the cruel part. This isn't a world where willpower is fighting hunger. It's a world where willpower is fighting industrial design, social norms, convenience, stress, lack of sleep, and constant cues to eat. So yes, individual choices matter. But so does the environment your biology is trapped inside. What fat actually is. When you consume more energy than your body uses, the surplus gets stored, mostly as triglycerides, a dense energy molecule. Think of triglycerides as charged batteries. They are packed into fat cells, called adipocytes, as one big oily droplet. When you gain weight, adipocytes can expand dramatically. When you lose weight, they shrink. But storing energy is only half the story. The bigger discovery, relatively recent in medical history, is this. Fat is endocrine tissue, meaning it behaves like a hormone organ. Your fat cells release chemical messengers, often called adipokines, that talk to your brain, liver, muscles, immune system, blood vessels, and reproductive organs. Fat helps manage hunger, energy use, fertility, inflammation, and even immune behavior. A healthy fat organ is like a calm logistics department, tracking supplies, sending signals, coordinating systems. But when the organ grows too big and too stressed, it can turn into a chaotic emergency broadcast tower that never shuts up. The two main fat worlds, subcutaneous versus visceral. Most body fat in adults sits under the skin, subcutaneous fat. It's the soft padding on hips, thighs, arms, and belly. Subcutaneous fat isn't harmless, but it's often less metabolically destructive. The other major type is visceral fat. Visceral fat is stored inside your abdomen, wrapped around organs like the intestines, liver, and pancreas. It cushions your insides, but it's also more hormonally active and more linked to metabolic disease. That's why two people with the same body weight can have very different health risks. If most of your fat is stored away from organs, more pear-shaped, risk tends to be lower than if more fat is stored in the abdomen, more apple-shaped. This isn't about moral worth. It's about biology and distribution. Visceral fat tends to be more responsive to stress hormones like cortisol and adrenaline, and it can release fatty acids into circulation more readily, fuel that can become toxic in excess. When fat cells start to suffocate. Fat doesn't become dangerous just because it exists. It becomes dangerous when it becomes overcrowded and stressed. As adipocytes expand, they start outgrowing their blood supply. Less oxygen reaches them. This creates hypoxia, a state of low oxygen inside expanding fat tissue. Cells under oxygen stress behave differently. They release distress signals. Some die. Some leak fat. Some become dysfunctional. And when cells die, your immune system notices. The immune system moves in and never leaves. Your immune system is built for emergencies. If you get a cut, immune cells rush in, clean up, and leave. Short inflammation is protective. But obese fat tissue can create something else. Chronic, low-grade inflammation, a slow burn that never ends. One of the most important immune players here is the macrophage, an immune cell that eats debris and coordinates inflammation. In lean fat tissue, immune cells are a small minority. In obesity, macrophages can become a huge fraction. Some research reviews describe adipose tissue macrophages making up as much as 0.40% of cells in obese adipose tissue, clustering around dead or stressed fat cells. Imagine a neighborhood where houses keep catching small fires. Firefighters arrive, but the fires never stop. So the firefighters set up permanent camps. Sirens become constant background noise. That is your inflamed fat organ. How chronic fat inflammation damages the whole body. Inflamed fat tissue releases inflammatory molecules that circulate through the bloodstream, and visceral fat, sitting close to the liver and draining into it, can be especially influential. This can contribute to fatty liver disease, insulin resistance, blood vessel dysfunction, higher blood pressure, higher triglycerides, higher risk of cardiovascular disease. Inflammation also affects the lining of blood vessels, your endothelium, making vessels stiffer and more injury-prone, raising the odds that plaques grow and circulation suffers. The result is not one single obesity disease. It's a broad shift in body chemistry toward damage. Obesity is a system-level problem because the organ involved, fat, talks to everything. The hunger insulin signal that stops working, leptin. One of fat's most famous hormones is leptin. Leptin is like a fuel gauge message from fat to brain. Energy stores are okay. You can calm down. Appetite can drop. In many forms of obesity, leptin levels rise with fat mass, but the brain stops responding properly. This is often called leptin resistance, and modern research supports that it is common in typical obesity, in a way that can resemble insulin resistance. So the body fat is shouting, "We have plenty." But the brain hears, "Are we starving?" This mismatch helps explain why many people with obesity feel intense hunger even when their bodies have abundant stored energy. It's not a character flaw. It's a broken signal system. Hormones, fertility, and cancer risk. Fat tissue also interacts with sex hormones. In obesity, hormone balance can shift, sometimes lowering testosterone, altering estrogen dynamics, and affecting reproductive function. And there's another uncomfortable truth. Excess body fat is linked with increased risk for multiple cancers. In the US, being overweight or having obesity is associated with a higher risk of 13 cancer types, and these cancers represent a large share of all cancers diagnosed. This doesn't mean fat causes cancer in a simple way. It means fat-driven biology, like chronic inflammation, altered hormone signals, and higher insulin levels, can create conditions where tumors are more likely to form and grow. Cancer is complicated, but the metabolic environment matters. The main explosion: insulin resistance. Now we reach the most important turning point in the story. Insulin is one of your body's key metabolic hormones. When you eat carbs, or anything that raises blood glucose, your pancreas releases insulin. Insulin tells cells, open up, take in glucose, use it or store it. But chronically inflamed, overfed tissues, especially liver and muscle, can begin to ignore insulin's message. That's insulin resistance. The pancreas responds by producing more insulin, like a boss whose employees stopped listening, so they start yelling louder. For years, this can be silent. Blood sugar may be only mildly elevated. You might feel a bit tired, hungrier, foggy. Eventually, if the pancreas can't keep up, blood sugar rises further. That's the path toward type 2 diabetes, a disease deeply tied to insulin resistance and chronic metabolic stress. What high blood sugar really does. High blood glucose isn't just a number. Glucose is reactive. Chronically elevated glucose contributes to damage in blood vessels and nerves, and stresses organs that filter the blood. Over time, uncontrolled diabetes is linked with kidney disease, vision loss, nerve damage, higher infection risk, slower wound healing, cardiovascular disease. Type 2 diabetes can significantly reduce life expectancy, especially when diagnosed earlier in life. One large analysis reported that earlier diagnosis is linked with fewer years of life expectancy, roughly 3 to 4 years lost for each decade earlier diagnosis. And projections warn diabetes prevalence could rise dramatically if trends continue. A CDC analysis famously suggested as many as 1 in 3 U.S. adults could have diabetes by 2050 under some scenarios. Here's the weirdly hopeful part. This is the part that doesn't get enough attention. Many of the harmful metabolic effects of excess fat are improvable. When fat tissue shrinks, oxygenation improves, inflammation can decrease, and insulin sensitivity often improves. Even people with type 2 diabetes can sometimes achieve remission or major improvement through sustained weight loss and lifestyle changes, especially earlier in the disease course, though not everyone responds the same way. And medical guidance matters. The body is not fragile glass. It's often more like a healing forest. But healing requires time, consistency, and support, not shame. So what actually helps? Without magical thinction. There is no single hack. There is no one diet that solves obesity for all humans. But there are consistent patterns that help most people, especially when combined and sustained. Make fullness easier. The modern food environment makes it easy to eat lots of calories with low satiety. Generally, diets that increase protein, fiber, minimally processed foods, water-rich foods, vegetables, soups, fruit tend to improve satiety per calorie. Ultra-processed foods often do the opposite. They can be calorie-dense, quick to eat, and easy to overconsume. This isn't moral. It's physics plus biology. Add movement you can repeat. Exercise is not just burning calories. It improves insulin sensitivity, supports muscle mass, helps mood, and reduces cardiovascular risk. Strength training is especially useful because muscle is a major glucose sink. More muscle often means better glucose handling. Even small increases in daily movement can matter when sustained for years. Sleep and stress are not side quests. Chronic sleep deprivation alters hunger hormones, cravings, and impulse control. Chronic stress raises cortisol, which can increase appetite and push fat storage toward the abdomen in susceptible people. You can't biohack your way out of an environment that keeps your nervous system on fire. Medical tools can be legitimate. For some people, obesity is not meaningfully treatable with lifestyle alone, because the body defends higher weight through powerful appetite and metabolic adaptations. Modern obesity medicine includes structured behavioral support. Medications, including GLP-1-based therapies for some patients, and bariatric surgery for appropriate candidates. These aren't cheating. They're treatments for a chronic disease when indicated and supervised. The biggest lever is societal. Individuals can make changes, but the epidemic scale suggests a larger culprit: food environments, advertising, urban design, poverty, stress, and availability. Policies that reduce aggressive marketing to children, improve school food environments, and make healthy food cheaper and easier are not nanny state. They're public health. And they may be essential. A different way to talk about bodies. If you take one idea from this video, let it be this: fat is not a personality trait. It's a biological organ that responds to your environment, your hormones, your sleep, your stress, your genetics, your medications, your income, your culture, your trauma, your time, and the food world you live inside. Some people gain easily. Some people don't. Some lose easily. Some don't. But the science is clear on two things at once. Excess visceral fat over time can be dangerous. Shame is a terrible treatment plan. The goal isn't to fear fat. The goal is to understand it, so we can reduce harm with empathy, tools, and systems that actually work. Because the fat organ isn't your enemy. It's a vital system that can become sick. And sick organs deserve treatment, not blame.